Okay, everyone, welcome to Advanced Visualization. We left off with basic data viz with Victoria, creating our first plots with ggplot. And today we're just going to build upon that. So we'll navigate over from the homepage of our website to Advanced Viz. And here we are. So I'm going to quickly go over the different types of visualizations just on this website, but then we'll go over to RStudio and jump in the code together right after that. So today's topics are going to be customizing visualizations, making static visualizations interactive with the Plotly package, and creating interactive maps with the leaflet package. So we'll start by loading in libraries. There will be some new libraries here, so we'll have to install them in the console. We'll go over that once we're in RStudio. We read in our SDR 2023 data with read CSV in here. We clean the column names, and then we customize a histogram. So this is a histogram that you made yesterday or in the last video with Victoria about goal 4 scores and regions. Well, now let's improve it. So we're going to do 3 major things. We're going to add a theme with theme minimal, the function, add a color path with the function scale, fill, varieties, and then we're going to add a title, x-axis label, y-axis label, and a legend label with the labs function. So here's what this looks like. We're adding to our plot, so you can see these first 2 lines are identical, the first 2 lines of this code. But now with plus signs, we start adding. So we start adding here, theme minimal. We'll go over the different types of themes when we're in RStudio together. And then we add our scale fill function, scale fill varieties. And then we, with the labs function, add a title in quotes and y-axis, an x-axis label, and a legend label. And it looks like this, right? So a little more custom made than this. I think it looks sharper with the white background. I think this is a better color palette than the default color palette. We have a nice SDG 4 score here and a number of countries labeled here, as opposed to just count and the underscored goal 4 score. So yeah, just a few simple lines of code, I think, to improve this plot a whole lot. However, it's still a little tricky to tell exactly how many countries in each region have the SDG score, right? So we can look at these bins and get pretty close. But I think a cool thing would be to make this plot interactive with ggplotly. So making static visualizations interactive is a really exciting part of data science because interactivity engages the viewer by allowing them to explore the data in a way they cannot with static or static visualizations. Yeah, so if you think about the maps we clicked on in the SDG data landscape video in that beginning video, we're able to select columns and trends and SDG scores themselves. That was a really neat exercise and it allowed us to learn. So we want to provide experiences like that. And the first basic start of getting into that is just with ggplotly to allow users to hover over the graph and see different trends in the data or different parts of the data based on what they select. And the great part is that ggplotly only has 2 very simple steps. So the first is to name the plot. So we name it here. We didn't apply a name in the beginning. We were just using the ggplot function right away, but we're naming it with our assign arrow. And then once we name it, as long as we install the Plotly package, which we mentioned up here, library Plotly, and we can use that ggplotly function, and in the function, put the name of our static plot. And with that, we'll get to hover over. So we can start to see, okay, there's 4 countries with this goal 4 score of about 98 and above in Eastern Europe and Central Asia. We can isolate scores by double clicking on the legend. So if we just wanted to look at Eastern Europe and Central Asia, we can do that. We can look at Latin America and the Caribbean and isolate just those. We can look at Oceania. We have a lot of missing data, but it looks like we have 1 country, right, in that like 95 area for goal 4 scores, and 1 country around 54. Here's what that looks like. I think it's really neat to be able to hover, and our hover will change colors based on what region we're showing in the histogram. And again, that just took two simple steps of naming the plot and then using this ggplotly function. So this is something I really encourage you to do in your final projects. Is any visualization that you can make interactive, I highly recommend doing so. We'll see in the machine learning video, those visualizations might stay better static. But if it does make sense to hover like this, I highly encourage you to do so. So now in challenge one, we'll provide the scatter plot code that you used in the last lesson. And we'll describe this a little bit more thoroughly when we're in our studio, but we're going to edit the code chunk to add themes, add a color palette, add axes titles, and then make it interactive with ggplotly so that we can hover over the points. So now we're at the final part of creating interactive maps with Leaflet. So this takes a few fun steps to do. Leaflet is a really popular package for plotting maps in R. I think it's the simplest to use. So that's what we wanted to present you with to just get you started. There are a ton of options if you're looking to make maps in R, but I think Leaflet is a good start. So there's a few things we need. We need data on countries and their physical location on the globe, right? So we need data about where these countries fall on a map in order to map them. And lucky for us, our natural earth package has that information for us. So here we name an object called world, and we use the any countries function from our natural earth to get the physical locations of those countries, the geometries. So I'll show you what that looks like in our studio as we continue on. And then we select the columns that we're interested in. We change column names so that we can then join the data with left join. Here's a cool resource on joining data. If you have a little bit of trouble with that or want to look into different joining methods. Change the class of the data frame to recognize the geometry, which we'll see in just a second. We then specify our coordinate reference system as this WGS84. Some information on coordinate reference systems and what they mean. It's a little deep for this lesson, but we just have to have it agree. And once we do that, we use Leaflet to generate this plot. And this plot is colored so that darker red countries have higher goal 7 scores, and the yellower or lighter the color get, the lower their goal 7 score is. So we see Canada with a score of 80.3. We see US with 73.5. We see Argentina with 73. Bolivia with 64. We kind of look and it presents the information in a way that's kind of more neat than a bar chart or something that just compares the data, not in this geographic sense. And we can start to see, are there patterns by continent? Some continents have higher SDG scores. Is it a region focused thing or is it really distributed and not so geographic focused? So we color, yeah, by SDG score 7 here. And we'll talk a little bit about how this code works in our studio in just a second. And in challenge 2, we'll have you edit the code chunk to change the SDG that you're mapping here. So changing the color of this map on a new SDG, so anything other than SDG 7. And we might have you change the color palette as well. And there's some cool color palettes here that you can use at this link. So now let's jump into our studio. Here we are with an empty console. If we go to the R Markdowns folder, to the advanced viz.rmd, and have a full screen here. And let's get into it. So our first code chunk is loading in some libraries. We have the tidyverse as always. Here, reading in file names. Janitor for cleaning names of columns. Plotly, this is what makes our static visualizations interactive. We have our natural earth that contains the geographic information on countries that we need to map. And we use leaflet and SF for mapping. So we'll go ahead and hit the run button on this code chunk to load in those libraries. You get any errors here, it's most likely that you have to install one of the packages. So read the error message. And if it says cannot find this package, you might have to install it in the console with this install packages function. And in quotes, you just put whatever package you're missing. So it's ever prompting that error message. And now let's go ahead and, as we've done before, read in our SDR data. If you notice that we keep doing this, it's because we're keeping our code reproducible. So every coding script, we want to start the same way, reading in the data, cleaning in the column names, and then doing some analysis on it. Because we need our code to run top to bottom, right? So every time we have to read in the data, clean it, and then start visualizing it. So that should exist in every R script in the course. And then we'll go ahead and, if we remember, these column names have spaces and capitals and things that might give us a problem. So we will use the clean names function to make our column name separated by underscores instead of spaces and all lowercase. And then we have that histogram that we started with. And we plotted in the last lesson. And here's where we add some code, right, to customize. So this, again, is exactly the same as above, but we add a plus sign here to start looking at theme. If we run this code, looks like this, right? So let's look. There's a few different themes that are pretty interesting. So when we type underscore theme, you'll see a lot of fill-ins here, right? That's like auto-populating, and these are all different themes that we can use. So I tend to like theme classic, theme black and white. So if we change this here, we can run the code and see how that changes our graph. Oh, and I actually got an error here because I actually forgot to add the plus. So that might be a good example. Without a plus here, there's no way for this code to connect to this. So we get an error message. So once we have a plus, that will go away. Now it looks relatively similar, but just with a little box around the plot here. Let's go ahead and delete this again and try another theme with theme underscore dark. We'll add our plus to connect the code. Now we have something that looks like this, also kind of interesting. So I encourage you to, jump in the code and play with those themes and see the differences. And I'll go back to theme minimal. A little typo there, theme minimal. Cool. And then we have the scale fill 3D function. And this is on different color palettes. So we have the underscore D because they're discrete. So regions are discrete, right? Not continuous variables like a number range. They're categories. So we use this discrete underscore D part here. And there are different options here. So this is like a purple to yellow. And if you type here, we have like option equals, the magma is one. So if we run that, we get like kind of a fiery graph here, right? So a little bit of a different color scheme. There's lots of different options. So if you Google scale fill 3D, so maybe we'll even leave a link there on the website for you to check out all these different color palettes. But there's a lot just within this function where you could choose different options. And there's so many packages to use different colors, and you can even manually assign hex codes and that kind of thing. But this is just an easy way to, I think, really make pleasant looking graphs with only one line of code. Then our last bit here, after another plus, is the labs function. So within labs, we can specify a few things. So the title will be the title of our plot. We'll make sure to put that in quotes. And then we get this distributions of SDG scores. X, we have as SDG 4 score, so that's what will appear right here. Y, we have equal to number of countries, so that's what appears right here. And fill equals region, so that's what appears over our legend. So that's how each of those work to create labels. It's always nice to have nice labels around our graph. It looks clean and professional, as opposed to underscores and things like count that happen off the default when we don't use the labs function. So yeah, we're looking much better. And now we wanted to make the plot interactive, ggplotly. So again, we name it here. I think a good name for this plot, right, might be goal 4 histogram. It's the first time we're naming a plot. So a lot of times we've assigned names so far to data frames or lists or things like that. But we can actually name plots the same way that we name those. So we named this plot geo or goal 4 histogram. And then we have the same code as we have above. And the only thing we do is use this ggplotly function and input the name of our graph. So whatever we name it, in this case, it's goal 4 histogram. And when we run this, this is where we can start hovering. We can look at just a specific part of the graph if we want with this feature and look at only the countries between 75 and 100. To double click, we get back to the main part of the graph. Again, we can isolate regions that we're interested in. We can start with just a blank graph or a blank graph completely. We can kind of build and see how that looks. So a lot of features just for one line of code, this ggplotly function, taking our static visualization that we have here and making it interactive. You'll notice this one is that purple to yellow color, right? Because we don't have option equals magma, but if we wanted to, we could add that to the code. And that's what it looks like here, right? So now we'll have this static visualization with the magma color become interactive. And this doesn't work for just histograms, right? This can work for scatter plots, it can work for bar charts, it can work for maps, it can work for all sorts of visualizations. So I really encourage you, again, to think about what you can make interactive. And if you can, use that ggplotly function to do so. And now we get to challenge 1 here. So here's the code for a scatter plot that you made in the last lesson. We use ggplot. We input the data we want to plot. And then in our aesthetic functions, we put the goal 3 score on the x-axis, the goal 4 score on the y-axis, and we color by region. And then we make a scatter plot with geom point. And I'm asking you to edit the code chunk above that generates the plot to add a theme with theme minimal, add a color palette with scale fill reduce, and add the appropriate title, x-axis label, y-axis label, and legend label with labs. So very similar to this part of the code here. We want you to add that to this code chunk. So I'd imagine you'd have a plus, and then you'd add that code and see how it changes, and see if you can customize it, change the color, change these labels to be nice without underscores, add a title to the plot, and make it interactive with that ggplotly function. So again, making it interactive would require you putting a name here in front of ggplot with an assign arrow, so naming the plot. And then whenever you name the plot, I would give yourself a new line and put ggplotly with the name of that plot. So I'll let you go ahead and accomplish that challenge. And we'll continue on with creating interactive maps with Leaflet. So this takes a few fun, easy steps to do. So the first thing, as I touched on a little bit earlier, is that we need countries and their physical location on the globe. And the Our Natural Earth package has that information for us. So we load it in, we install the package, right? And we load it in with our library, Our Natural Earth, up top here. And we use the function within the package, any countries. And we choose a scale equals medium, and we want the class of the object it returns to be an SF object. Simply means that it has just geometries and geospatial information in it. So let's run this. We're naming this world. Let's see what happens. So now in our environment, we have this object world, right? And here's what it is. It's got country names, it looks like, types, admin, all of this information, names, name long, right? Very similar. Abbreviations, postal. But essentially the most important data frame in this, it has information on, sorry, the most important column in this data frame is actually the geometry column. So we'll keep going. And we'll see that within this data frame, I believe the last column is geometry. So this is its physical location on the globe, and it's how we can plot with leaflet. So we have a lot of country or a lot of columns in that data frame that we don't necessarily need. What we're most interested in is the name of the country. It's ISO A3 code, which is just a 3-letter country code that's standard across. And then the geometry column that has that geospatial information that we need. So let's just use the select function. We're going to overwrite our data frame world, creating a new data frame where we just have these 3 columns that we're interested in using the select function. So when we run that, we go from over 50 columns to just about 3. And here we have it, name long, that 3-letter country code, and the geometries. So much simpler data frame to work with. And now we're almost ready to join that data frame with our SDR data, because when we're plotting, we can only plot from one data frame at a time, right? So if we're making a map, we can't use our SDR data and our world data with the geometries. We need to put them into one, so we can join based on the country name, right? Or the ISO3 code, the abbreviation, to join the data frame so that we have the geometries and our SDR data in one data frame. But to do that, we need to make sure that the world data frame and the SDR data frame both have the same columns for the ISO3 codes. And they actually don't here. So if you'll notice, in the world data frame, it's ISO underscore A3. And in SDR data, it's country underscore code underscore ISO3. So it's really important in order to join the data frames, even though they contain the same information, those column names need to be the same. So we could change one or the other. In this case, we choose to change the name of SDR data from country code ISO3 to just ISOA3 to match world. So we're changing this to match what it is in world, ISOA3. So this is how we change the column name. So when we run this code, you'll see that in STR data, this is now ISOA3, which matches exactly what it is in world. And now we're ready to join. Again, if you're interested in joining data in different ways, check out this cool resource. And we're going to use the left join function. So the left join is interesting. A lot of times we use full join and just merge all of the data together. But our world data frame had 241 observations, if you can see in your environment here. And our STR data only has 206 countries or observations. So we don't need all the geometric locations for countries that aren't in the SDR data, right? Because at this moment in our analysis, they're not very relevant to us. So we're just going to take the geometric coordinates from world for only the countries that are in SDR data. So that's why we're using a left join. We use the full join. We just get all the data together. So we'd have lots of NAs for the countries that are in world, but we don't have any SDR data for them. So we're going to use a left join. And if you need more explanation on that, there's tons of resources to look at different types of joins and why you might want to perform one or the other. But we'll go ahead and we'll make this new data frame called SDR data world underscore joined. And we'll use the left join function, that left join here. And all we need in the left join function are the 2 data frames we want to join. So SDR data and world. And we're going to join these data frames by the similar column, ISOA3. So by the column that they share. Since we changed the names, they both have that ISOA3 column. So when we do that in our environment, we can check it out. And now we have our SDR data, as well as, if we scroll all the way, and we can save ourselves a little bit of time, we'll have a geometry column at the end here. So here's all our SDR data with those ISO-A3 codes and where they physically are on the globe. And now we are almost ready to go. So we gotta check the class of this new data frame. And you'll see it says here data frame, but what we need for the leaflet package to work is that it's an SF object. So we need to change the class from just a normal data frame to an SF data frame. So to do that, we can override and just say SDR data world join. We want to transform this to an SF data frame with the function st as SF. So we'll transform this here. And then when we check the class, we'll see it says SF here. So that's what we really need in order to be able to put this into the leaflet function successfully. So the class up here of not having SF, that wouldn't work in leaflet. But since we transformed it to an SF data frame, we now have the spatial features and it recognizes that geometry column as what it needs to use to plot the map. So just a slightly technical step there, but it's just necessary in order to generate. And the very last step before using the leaflet function are those coordinate reference systems. So there's a little bit of info here on coordinate reference systems. There's certificates at Chaminade about geospatial data and using different coordinate reference systems for different reasons. We're going to stay away from all that technical stuff for now. And we're just going to use the st transform function just to use this coordinate reference system specifically. It is one of the most common coordinate reference systems, but we just have to identify it here. So don't worry too much about this chunk of code. It's not something that you'll have to change or edit. But if you are making leaflet maps in the future, you might have to think about coordinate reference systems. And now we're ready to go. So we're going to run this code chunk here. And there's kind of two parts. The my text bit is what determines what happens when you hover over each country. So we want it to say country. So what country it is. So that will be country colon, the data frame, and the $ country. So whatever country you're hovering over should appear after this country colon. And then we want the goal 7 score to appear as well. So we're going to round from our data frame, the goal 7 score that you're hovering over. And then we're going to use leaflet. So we'll use leaflet to put in our data frame here, our SDR data world joined. And where we get to specify that we want goal 7 score here is within this color quantile function. So this is where we specify we want to color the map by goal 7 score right here and here. And this is where we specify what color palette we'd like to use. So there's lots of different color palettes at this website here that you can check out. But those are the main parts of this code that you want to think about. So determining what happens when you hover, and then using leaflet, putting in the data frame that we want to plot from, and the score or the column within our data frame that we want to plot. So when we run this, that's what generates this map. And we can zoom in, we can hover. As you can see here, it says country colon United States. That's exactly what we put here with country colon, and then the country that we're hovering over. Then it says goal 7 score, 73.5. So that's what we mentioned here. So if we change the score, right, from goal 7 to goal 9, we would want to change this as well, right? Because when we hover, we don't want it to say goal 7 score when we change this to goal 9, because that would be a little misleading, right? So we'll want to change that goal 7 score to reflect whatever we have in here. So now for this challenge, we want you to edit the code chunk above that generates the map to map a different SDG score. So inputting a different SDG score here and here. And then we want you to look at these color palettes at this link and try to use something other than yellow, red. So within quotes here, you could put other color palettes you could find at that website linked and try to make the map have a different palette and see what you like. Do you like the yellow to red? Do you like maybe a purple to blue kind of scale? And when you run that, stick with what you like. And then, yeah, just think about the patterns that you see in the goal. Is it geographic? Is it kind of continent driven? continents share kind of similar goal scores in that, or is it distributed kind of unevenly, not by geography? So again, as always, if you have any questions on this, please email connor.flynn@chaminade.edu or jump in one of our office hours with either Victoria or myself, and we'll be happy to talk through the code that we wrote, some of the theories, want to get more into coordinate reference systems or anything in that capacity, or how to use ggplotly and make plots interactive in cases other than just the scatter plot or the histogram we showed you. That would be great. So jump in, and I encourage you to stop by. Thanks.